And good morning, afternoon, evening, or whatever time it is. It is time for pre-calculus. And today we are going to learn about logarithmic functions and their graphs. Or as I like to say, we're going to play with logs. And now, a little brief reminder that if you have any questions on your homework, please let me know, because on the last homework, no one asked any questions. So therefore, we're just going to do section 3.3, and then maybe I'll explain some questions on 3.2 if you send them to me. All right, let's see what we got here in section 3.3. All right, so logarithmic functions are in essence the inverse of an exponential function. Okay? So what they actually determine, f of x here, is the exponent. Okay, so the logarithmic functions determine the exponent. So it looks like this. Okay, you have a base, log of some base, that is the same base as the base that's getting raised to a power. And what you're inputting into it is actually the answer of b to the x power. And you'll see that over and over again in this lesson. Okay. So here's some stipulations on it. Okay, so, x has to be greater than 0 because exponents always give you positive numbers. Okay, they don't give you numbers less than 0. Anyhow, so basically this shows you the connection between the exponential function form and the logarithmic function form. Okay, IFF stands for if and only if. So this is true if this is true and vice versa. All right, so this is good to remember here. So the log of a base of some number is equal to the exponent. Okay, so you want to think, like when you're determining a log, like 10 to what power gives me this number. Okay, and then you're looking for the exponent. Okay, so it's good to keep this in mind. So I already said all this here. All right, let's look at some examples. Okay, so when you're determining like log of base 3, log base 3, 27, okay, we're thinking in our heads, 3 to what power is 27? Okay, so 3, what exponent will give you 27? All right, and that is, well, 3, of course. Okay, 3 to the third is 27. 3 squared is 9. 3 times 3 is 9. 3 to the third is 3 times 3 times 3, which is 27. Okay, so log base 3 of 27 is equal to 3. All right, log base 10 of 100. So you ask yourself in your head, think about this. 10 to what power is 100? So that's just 2, okay? So this answer here is 2. All right, let me exit out of here so I can actually write on here. Nope, can't write on there. All right, anyhow, this one's a little bit trickier. 5 to what power is 3 cubed root of 5? All right, now remember, fractional exponents actually become cube roots. So like the denominator of the fraction becomes the cubed root, okay? So it's like 5 to the first inside of the root with the cube root on the outside, okay? So if you see you're getting some type of root, then you will probably be raising to a fractional exponent, okay? So like if this was just a square root of 5, it would be the answer to the 5 to the log base 5 to the of square root of 5 is equal to 1/2. Okay, so anytime you get a square root, it is going to be a fraction, or a cube root, it's going to be a fractional exponent. Okay, calculator note. The log key on your calculator is actually always base 10. Okay, it will just appear as log on the calculator. So when you just see log, that is understood to be base 10. Okay, so it's 10 to what power? Okay. Yes. The other logs, except for the natural log you cannot do on the calculator. Natural log is ln. Okay, we'll talk about that in a second. All right, here's another one. 15 log base 15. So you think 15 to what power is 1? Okay, well, how can you take 15 raise it to the power get 1? That's 15 to the 0 power. Okay, remember anything to the 0 is always 1. All right, so here are some properties of logs, which are kind of neat. Okay, so like anytime you get 1, remember that is raising it to the 0 power. If it is the same, okay, as the base, then it's just raising it to the first power. Okay, if it is the base plus an exponent, then your answer is just, well, the exponent, okay? So basically when you have a base and a power, when you have a log and a power, the log cancels out the base of the power and you're just left with the exponent. And it works this way too, okay? So the base cancels out the log and you're just left with the exponent, x, okay? Kind of neat. Okay, more examples here. So you think 4 to what power is 64? Well, these examples here all use those properties that you just saw. Okay, so you want to think like, which property could I use on these ones? Okay, so this one is using that property right here, the one that I mentioned where the log base cancels out the exponent base and you're just left with the exponent. Okay, so that's just equal to 3. You could still think 4 to what power is 64, and you might know that's 3 too. Once again, here, the base cancels out with the log, and you're just left with 23. Okay. On to common logs. Log base 10. So that's just another name for a log base 10, a common log. And that's where the logs you can actually do in the calculator. And so if you see log x, that means log base 10. Okay, so understood 10 here. All right. So in this example here, it's saying like 10 to what power is 1,000? That's just 3. Okay. And the properties of the common logs are just the same as the properties of regular logs. Just remember there's this understood base 10 on all of them. Okay, so it hopefully makes sense here if you look at the becauses. Okay, why this is true. Okay, so remember E. E is that special number, that has to deal with infinitely many compounding times of interest. Okay, so logarithmics with base E are called natural logs. So if you see ln, okay, now the reason why it's natural log because that is the French or whichever language called it log de naturel, just like they like to put the adjective after the noun. So that's why it's ln and not nl, but that's all right. Okay, so natural log of x, you're really thinking base E here. Okay, so like E to what power is equal to x. Okay. All right, so y is the exponent that will give you x. If you take e to the y, that's equal to x. All right. So remember, base e. So these properties are actually the same thing as the common log properties. So just remember there's a base e on all of these. So you're thinking, okay, for this one, e to what power gives me 1? That's e to the 0 power. And then this one, it's, e, remember the base is e, so e to what power gives me e? And that is 1, okay? Because of the same thing, to get the same thing, you raise it to the first power. So these properties are all the same. When you're graphing a natural log function, really this is, let me pull up Desmos here so I can show you what it looks like. But these are all the different features of it here. It is kind of like an exponential function, only it grows more gradually. So let's check it out here with good old Desmos. But it's loading. Okay. ln natural log of x. So difference here, okay, compare this to a exponential function, which is actually its inverse, okay, it cancels out the exponential function. Basically, y and x switch, okay, so any point that you have here in the blue graph becomes the point in the red graph, okay, and it's symmetrical across y equals x, so there's this odd symmetry going on here between natural log of x and e of x here. So actually, natural log of x has the possibility to have an output of negative numbers, okay? So that's because you could, in essence, put negative numbers into this exponential e to the x, okay? You could put negative numbers into this e to the x for x, and they would give you an output of positive fractions, because like e to the -2 would be 1 over e to the +2. So in essence, you know, you can have output of negative numbers, but you cannot have input of negative numbers, okay? Unlike with the exponential function where you could actually input negative numbers, natural log has no negative inputs. So if you look here for the domain for the natural log, it's 0 to infinity. The range, the y values is all possibles here. And there is a vertical asymptote at x equals 0. There is no horizontal asymptotes in this case. And you do all the transformations just the same, okay? So like, you know, you could do horizontal shifts if you have like parentheses around the x here. Okay, so here's a couple more examples of evaluating logarithms. So here you're thinking 3 to what power is equal to 81. So you might want to, you know, just start multiplying 3's a bunch of times till you get to 81. Okay, so you could rewrite 81 as 3 to the 4th power, so this one's just equal to 4. Okay, now this one, log base 10, so 10 to what power is equal to 10 to the -4th power? Well, that power is -4. Here, okay, remember, base of natural log is e, so e to what power is equal to e to the -4th? That's just equal to -4. Okay, the -4th power would make that true. Okay, so evaluating this without a calculator. So remember, log base 10, okay, if it's, you know, doesn't have a number here, the base is 10. So this 10 will cancel out this log base 10, and you'll just be left with 14. Okay, hope that makes sense. Lots more examples here. So in this particular one, they're actually telling you what the exponent is. You're looking for like what you're inputting here, okay? So you're thinking 10 to the -3rd power is equal to x. So you have to kind of follow it like in a little circle here. Okay, so think 10 to the -3rd is equal to x. So x must be, remember negative exponents, you can rewrite as a fraction, 1 over 10 to the 3rd. So that's 1,000th. All right, the next one. So you're thinking e, okay, to the 5th power is equal to x. So then you actually have to go in your calculator and type in e to the 5th power to get a decimal approximation, which is that. All right, you have to hit the second natural log key to get the e. Okay, now to change this to logarithmic form here, what you would have to do is you can actually apply a natural log to both sides in order to cancel out the base e here. Okay, so let's do natural log to both sides. Okay, and that will actually cancel out the base e, and you would just be left with x. So it kind of, I would actually switch this around, but you're applying a natural log to both sides. Okay, so ln of e, that will cancel out. The natural log cancels out the e, and that just gives you x. And you have natural log of 7.3, and you can just put it in the calculator to get the answer there. All right, so that's about it for this one. Running into the limit mark, I'll explain the last one by typing it out. And have a nice day, guys. Take care now.